Page 188, question number 9. Use the diagram below to help answer these questions. So this is a diagram here. Now notice that it is a unit circle because the coordinate of A is 1 to the right, so that's the radius. So it's a unit circle. And we're going to see we're going to answer these questions based on that unit circle. So what is the equation of this circle? That's the first part. The equation of the circle is going to be, well, the x coordinate, x squared plus y squared equals 1. Okay? X squared, the x position squared plus the y position squared is equal to 1 squared. So it says the coordinates of C are negative 2/3 and positive root 5. Okay, so I'm just going to put that in negative 2/3 and positive root 5, and just confirming that this is a radius 1. I can square that. I get 4 plus 5 is 9 over the rate 9, so that gives me 1. So that definitely is radius 1. And it says here, what are the coordinates of B? Well, the coordinates of B are going to be based on this triangle here. And if you notice that this triangle that I'm outlining in blue, that triangle is the exact same triangle, but in a different orientation that I'm going to use for B. And I can see that the vertical length of the blue triangle is now the horizontal length of the red triangle. So I know that that was 2/3 that's going to be root 5 in the positive direction. This is now going to be root 5 over 3 in the positive direction. The horizontal distance now is going to be root 5 over 3, and it's in the positive direction. For the blue triangle, the horizontal length, the longer length, is negative 2/3. Well, that's the same as the vertical length, but now it's going to be positive 2/3. So then this coordinate is going to be root 5 over 3 and vertical position of 2/3, positive in both cases. So we can use that triangle to do this problem. Now, I just want to show you something on the side here that is very useful if you've never seen this before. The 90-degree rotations, so if I have a point here, I'm just going to arbitrarily put a point here, that's going to be A in the x direction, B in the y direction. If I were to draw a circle in here and rotate that 90 degrees, the 90-degree position is going to be here, and it's always going to give us the same triangle, essentially. And we're going to end up with negative B, positive A. So that first coordinate was AB. That next coordinate just switches, so B is X, A is Y, but then 1 is going to be negative. And that pattern is going to just exist all the way around the circle. So I know that here, I get the same triangle. That's going to be, that point here is going to be, I'm going to have a distance of negative A. So instead of positive A, I'm going negative A. Instead of going up B, I'm going down B. And then the same can be said. So notice that from the yellow to the blue, again, we switch the X and Y, and we make one of them negative. And the same thing then is done when we rotate it another 90 degrees. So every 90-degree rotation is just going to switch the X and Y and change one of them to negative. And that actually reflects the idea that if we find the perpendicular slope, we're just switching the rise and run and making one of them negative, sort of the negative reciprocal. And that's the same as switching the X and Y when we rotate 90 degrees. And that's why that negative reciprocal slope is being reflected in this diagram. Okay, so part C says the measure of AB is theta. So we often define the theta as the angle here, but technically it is the length of that arc in the unit circle. That's actually how we originally defined it. We kind of don't really use it in that way, but theta is actually, radians is actually a length in the unit circle. So that distance from A to B is our angle theta. And find what is the expression to measure the A to C? Well, A to C is going to be, so the arc AC is equal to the original theta. Okay, actually, I'll do that in blue. My original theta, the length theta, plus the length from here to here, which is going to be pi over 2, which then can be expressed as a length on the arc as pi over 2 as well, since it's a unit circle. Okay, so the arc from A to C is going to be theta plus pi over 2. Part D, so this is part C, I'll just maybe label that. Part D says let P theta equal B. So the position of the theta angle is B. In which quadrant is theta the position of theta minus pi over 2? Well, theta minus pi over 2, I start with that position B, and I'm going to go backwards 90 degrees. So there's my 90 degrees here, backwards. It's going to be here. So this is my P of theta minus pi over 2. That's going to be locate that position. So that's going to be for D, it's going to be in quadrant 4. Okay, is where we're going to locate that angle, that position when we go backwards 90 degrees. And then lastly, what's the max and minimum value of the x and y coordinates? Since it's a unit circle, the max, y max is equal to +1, y minimum is equal to -1, x maximum is going to be furthest to the right, which is +1. X minimum is going to be furthest to the left, which is going to be -1.